All right, so this is the homework solving rational equations. So for number 1, it says the student solves the equation 4 over x minus 3 equals x over x minus 3 and obtains the solution 3 and 4. Are either of these extraneous solutions? Well, if the students solve this, just based on the domain restriction, because we know that the LCD is x minus 3, and based on that, your domain restriction is x cannot equal positive 3. So since he obtained x equals 3, x equals 3 is an extraneous solution because it goes against the domain restriction. All right, so let's take a look at number 2 now. Okay, so for the LCD, we have 2x and x plus 6. There's nothing in common, so the LCD is going to be 2x times x plus 6. For my domain restrictions, x cannot equal. So you can set each one equal to 0. So 2x is equal to 0 and x plus 6 is equal to 0. And when you solve these, you can see that this would be 0. So x cannot equal 0, and this one would be negative 6. So these are your domain restrictions that make the denominator 0. Now from here, what I'm going to do is I'm going to multiply the numerators by the LCD. And I may run out of space, so I'm just going to write it down over here. So we have 4 divided by 2x equals 5 over x plus 6. And you can easily just cross multiply if you want to, but I'm going to continue doing what I do. I'm going to multiply the numerators by the LCD. So 4 times 2x times x plus 6. And on this side, 5 times 2x times x plus 6. So here I see the 2x's are common, so I cross those out. And 4 times x plus 6. And on this side, I can cross out the x plus 6, and I have 5 times 2x remaining. So from here, I can distribute 4 times x is 4x, 4 times 6 is positive 24, and 5 times 2x is 10x. Now this becomes a two-step equation. So what I'm going to do first is I'm going to take the x to one side. So I'm just going to subtract the 4x over to this side so I can isolate it from the constant. So I get 24 is equal to 6x. So we'll continue this right here. So 6x is equal to 24. We're going to divide both sides by 6. And it appears that x is equal to 4. And when I compare it to my restrictions, just x cannot equal 0 or negative 6, which it doesn't, so this answer checks out. All right, let's go ahead and take a look at the next one here. So for the next one, LCD, once again, they have nothing in common. So my LCD is 2x plus 7 times x minus 1. All right, and it looks like I have some room right here. So restrictions. Domain restrictions, x cannot equal, what makes this 0 is 1. And this one, when you subtract 7 and divide by 2, you get negative 7 halves. So I'm going to work it out right here. Maybe I can do it all in a straight line. So first, let's start with our equation. We have x divided by 2x plus 7 equals x minus 5 over x minus 1. So once again, if you want to cross multiply, feel free to. I'm going to multiply the numerator and denominator by the LCD. Sorry, just the numerator by the LCD, my bad. All right, so for the first one, I see I can cross out 2x plus 7, leaving me with x times x minus 1. So x times x is x squared. X times negative 1 is minus x. Equals, on the right side, I can cross out x minus 1. So we're going to have to FOIL this out. So 2x times x is 2x squared. 2x times negative 5 is negative 10x. X times 7 is 7x. So negative 10x plus 7x is minus 3x. And then negative 5 times 7 is minus 35. Since we have this quadratic part here, we're going to bring everything to the same side. Actually, we have two of them, x squared and 2x squared. I'm going to keep x squared positive, so I'm going to subtract x squared from the 2x squared, because that'll give me a positive, and I'm going to add x over at the same time. So when I do this here, I get 2x squared minus x squared is x squared. Negative 3x plus x is minus 2x, and then minus 35 equals, these cancel out to 0. And then I can factor this to x minus 7 times x plus 5, and you can verify that by refoiling it out. So then my solutions become x equals 7 and x is equal to negative 5. I check my domain restrictions. X cannot equal 1. X cannot equal negative 7 halves. So both answers are correct. All right, for number 4, it says identify the LCD of the rational expressions in the equation. Okay, so for this, I'm just going to write the LCD, or the denominator for each one. So the first one is x plus 3, the second one is x, and the third one is x. Okay, so this is grouped together. So remember, you at least need two fractions to have it in common. So we can see they have the x in common here. So that's what's in common, and that's it. There's nothing else in common. So my LCD, what they have in common is this x. What's not in common is x plus 3. And this gives me my least common denominator, x times x plus 3. All right, for the second one, I'm going to write all three of them again. So I have x plus 1, x plus 4, and a 2. So when I look, none of them have anything in common. There is just nothing. So what's not in common is the 2 times x plus 1 times x plus 4. So my least common denominator is this right here. All right, moving on to 6, 7, and 8. All right, so for number 6, let's put this over 1 to begin with. And we can see they have nothing. We have a 2, an x, and a 1. There's nothing in common. So what's not in common is 2x and 1. So 2 times x times 1 is 2x. For your domain restriction, you could say 2x equals 0. When you divide by 2, x equals 0. So therefore, x cannot equal 0 because that's the value that makes the denominator 0, and it becomes undefined. Okay, now this one's kind of a small problem. So I'm just going to take the LCD and place it above each one. So place the 2x there, the 2x there, and the 2x there. So it's like 2x times 3, 2x times 1, 2x times 2, and divided by these denominators. So when I'm looking for common factors, so in the first one, I see that I have a 2 in common, so I can cross those out. And that leaves me with 3 times x, which is 3x. The second one, I see I have an x in common, so I cross those out. And I have 2 times 1, which is positive 2. And then the last one, 2x, there's a 1 at the bottom, so nothing cancels out. So 2 times 2x is 4x. So again, we have to isolate the variables. So I'm going to subtract the 3x to the other side so that it's isolated. And I come up with 2 is equal to x, and that's actually your answer. So x equals 2 is my final answer. Check the restriction, x cannot equal 0, so this answer checks out to be okay. All right, for the next one, let's put this over 1. Again, we have nothing in common. This is an x with no number connected. This one has x minus 4, so this is one factor by itself. So my LCD is x times x minus 4. Again, you can set each one equal to 0. If I set this x equal to 0, it would be 0, so x cannot equal 0. If I set this equal to 0 and add the 4, x equals 4, so therefore x cannot equal 4. So these two restrictions are what make my denominator 0. All right, again, I'm going to put the LCD above each fraction, like I'm multiplying to the numerator only. X times x minus 4, x times x minus 4, and x times x minus 4. So for the first one, hopefully you can see the x minus 4's cancel. So I'm going to distribute x times x is x squared. X times negative 3 is minus 3x. Plus, now this one, nothing cancels, so x times x is x squared. 4 times x squared is 4x squared. X times negative 4 is negative 4x. Negative 4x times 4 is negative 16x. Equals, now this here we cross out the x because that's what's in common, and 3x times x is 3x squared, and 3x times minus 4 is negative 12x. And here I can actually combine a couple of things here, right? X squared plus 4x squared is going to be 5x squared minus 3x. Oh, actually I could have combined further. I didn't see that. I have negative 3x minus 16x, which is negative 19x. On the other side, I can combine. Now, since I have a quadratic function on both sides, I'm going to bring it to the side that makes it positive. So we're going to go ahead and subtract 3x squared from 5x squared. I'm also going to add the 12x to the negative 19x. So when I simplify it, 5x squared minus 3x squared is 2x squared. Negative 19x plus 12x is going to be positive 7x, and that's going to be set equal to 0. Here, when I factor it, the first step I'm going to look for is the GCF, and I see they both have an x in common, and that leaves me with 2x plus 7. Now it's completely factored just from that one step. So we set each factor equal to 0, and we solve for x. So the first one is x equals 0. The second one, when you subtract the 7 and divide by 2, you do get negative 7 halves. Check the restrictions, and we can see that x cannot equal 0. So what that means about this is an extraneous solution, so I'm going to cross it out, and my only answer is x equals negative 7 halves, because that does not go against the domain restriction. All right, we're down to our last problem here. So LCD, I'm going to write this one out so you can kind of see. So this is x, when you factor out the x, it's x times x minus 3. we have x minus 3, and we have an x. So what they have in common, these have at least an x in common, and this has the x minus 3 in common. So that right there is going to represent my LCD. So from here, what is my restriction? X cannot equal, so this would be 0. And if I set this equal to 0, it would be 3. So those are my restrictions. Next, I'm going to place the LCD above each fraction, and I'm going to cross out. So once again, if you've forgotten from class, the whole goal of putting this above in the numerator is to cancel out the denominators, so we're only solving the numerator. So for the first one, x squared minus 3x is x times x minus 3, so we cross all that out, and we're left with 18. This one, I'd like to bring this positive and make that a negative 6. I can cross out the x minus 3's, so negative 6 times x is minus 6x equals, here I can cross out the x's, and then we're going to do 5 times x is 5x, 5 times negative 3 is minus 15. Again, we're going to isolate our x's, so I'm going to go ahead and add 6x over here. So 18 equals 11x minus 15. I'm going to add the 15 back to the other side. So we have 33 equals 11x. And then last, we can divide by 11 on both sides to isolate the x, and we get x is equal to 3. Now the problem with that is my restriction says x cannot equal 3. So we cross this out. There are no more answers, so in this case, your answer will be no solution, since no answer actually exists. All right, let's go ahead and take a look at the back problems. Okay, for number 9, it says, so far in your volleyball practice, you have put into play 37 of the 44 serves you have attempted. Solve the equation 90 over 100 equals 37 plus x divided by 44 plus x. To find the number of consecutive serves you need to put into play in order to raise your server percentage to 90%. Okay, so they've already given us the equation, which makes it nice to do. So I'm just going to write it here. We can figure out the LCD if you want. Well, actually, let me just do that. Keep it consistent. So for my LCD, what's in common is nothing. What they don't have in common is 100 times 44 plus x. So I can put that above each one. So for the first one, we can cross out the hundreds, and we're left with 90 times 44 plus x equals, the second one we cross out 44 plus x, and we have 100 times 37 plus x. So when I distribute it 90 times 44, let me go and see what that is. 3,960 plus 90x equals 3,700 plus 100x. Okay. Now, to solve this, I'm going to do this in one step here. I'm going to go ahead and subtract the 90 over to the 100x side. And at the same time, I'm going to subtract the 3,700 over to the 3,960 side. 3,960 side, sorry. And when I do that here, I come up with 3,960 minus 3,700 is 260. And then these cross out. And then 100 minus 90 is 10x. And last, we can divide by 10. And x is equal to 26, and that represents the number of serves. So you need 26 serves to reach that 90% based on the model given. All right, and last but not least, we have number 10 here. It says, use the graph to identify the solutions of the rational equation. And they already give us the equation and explain your reasoning. Well, I don't really need the equation because they gave me the graph, okay? And hopefully by now you understand just from Algebra 1 that the solutions are actually where the lines intersect, okay? So in this case, we have a hyperbola part of the branch of the rational function here, and we have a line here. So we can see they intersect at this point right here, which is -3, 4. So the solution is -3, 4. And when it says to explain your reasoning, I would say that the solution is where the graphs intersect. In this case, it's pretty straightforward. They intersect at -3, 4.